Hi, welcome to Tuts version 2.0. In this new series of episodes, I'll start from fresh and teach you about Node.js from the ground up. Tuts' original version started a long time ago, and some of the episodes are outdated and don't really apply to new versions of Node and the libraries that were covered. So I decided to create a new series, which I hope you will enjoy. In this first episode, we will cover Node.js installation, the event-driven principles, and our first Hello World application. So, if you haven't already, you should install the latest stable version of Node.js in your computer. For this, you should head out to the nodejs.org website, and if you have a Mac or a Windows machine, you can click on install. If you don't, you can head out to the download section and download the source code. And once you have it there, you can just unpack it like this. Cd into the directory, run the configure script, and then type make, and also make install when it's done. Also, if your system doesn't have the proper, doesn't allow you to install globally, your user to install globally, you may have to do sudo make install. So I'll just do that. It will take some minutes, and I'll just get back to you. Okay, so now we're done. So you should have the node binary on a command line available. So you can do node -v, could get the version that you just installed. And also you can start REPL, the read eval print loop, just by doing node. So node here, you can just do JavaScript commands as you would do on a normal node program. So let's do our first console log, hello world console log. So console.log and a string hello world. Okay, and it prints out hello world. Surprising. Okay, so now let's create an HTTP hello world server. So create a new file. Here we're going to call server.js. And first thing, we're going to import the HTTP module. So we're doing this by doing this part, which is require HTTP. We're naming the module here, and the require returns the module, and we're assigning the module into our HTTP variable. Now we have to create the server. So server equals http.create server, and then we have to create a function to handle requests. So this function will be called by the server every time there is a new request, and the server will hand out two objects to us. First one will be the request, the second one will be the response. So on the response object, we can reply to the client, and first off we can set an HTTP header. So response.write-head, and say 200 OK status, and then an object with the headers, with some headers we may send. So we can send content type, for instance. In our case, we'll set it to text plain, and also we should write the hello world string, hello world, and then we have to end the response. So we must register this function with our server. So we say server on request, call this handle request function, and also need to say that our server should listen to the port 8080, for instance. So let's try out this server. So node server, then open a browser window and type localhost 8080, and we have our hello world HTTP server. So this code is a bit verbose for all it's doing. We can trim it out a bit. So we can, for instance, get rid of the HTTP variable because we only end up using it once. So we can do require HTTP and then dot create server. Also, we can pass the handle request function into the constructor of the server, to the constructor of the server, so we can declare it before and then pass it to constructor, and the constructor will automatically assign it. So let's automatically bind to the request event this function. Also, we have another variable that we don't need here, which we only use once, which is the server. So we can just create the server and then make it listen on the port 8080. There are more things here. So the handle request function also uses the write hello world and then end, but end also accepts a string or a buffer, so it writes out that string or a buffer before it ends. So we can just put the string here and remove this function, and it turns out that we can also inline this handle request function, so we can also pass it directly here as an argument. So we can have it can have something more terse here, like this. So let me yes, no, this extraneous line. So let's try see if this still works. Yes, it does. Okay, so now I'm going to back off a bit and try to explain some advantages of asynchronous coding and why I think it's a superior programming model. So typically, when your code needs to go out and do some I/O, like when performing a query in a database server, your code can look something like this. So you do db.query and you pass in a string with a SQL query, and then that function returns the response. So the call to db.query is behaving like if it was a local call, but that function actually takes a very long time, at least in CPU scale, before it returns. May take some milliseconds, but this has a problem. So if you want to make a lot of calls, and those calls are independent from each other, we would have to make them in series, so like this. So here we're cycling and passing in the IDs we want to query. Let's say we want to query the IDs from 1 to 100. So this would take would make the queries in series. So if a query takes 100 milliseconds, the whole thing would take about 10 seconds. So we're not parallelizing anything. We're making one query after another. So to parallelize, we'd make to do some forking of the process or introduce threads here. And this has several problems. First, there is a overhead of forking or creating threads, and also the synchronization between them. So if any of these access the global state, there is a problem. We have to synchronize the access. So what is the synchronous alternative to this? So let's go back to our previous code, where it was like this. What we have to do is to define a response ready function. So something that will be called once the response is ready. And that response will be passed in as an argument. So again, this is all pseudocode. And we'd log the response here. And then we'd say, okay, this comes as an argument. This comes as an argument to the db.query. And db.query doesn't return anything that we really care about. So once this is done, response ready is invoked, and then we do whatever we want with the response. So now, if you wanted to parallelize a bunch of queries, what would you do? Okay, so we do this. So I'm just doing a cycle and then passing in the index variable here into the query, and then also passing in the callback, which in our case is just one function that handles any response, but we could change that easily. So this is much easier than the multi-threaded code, right? So how does Node.js work? So one important thing here is the event loop. So asynchronous I/O platforms work by using an event loop, and the loop can be simplified to two phases. First phase is wait for events. When events happen, you handle them. So the events happen, they get queued up, and then you handle them until there is no more events waiting in a queue, and then you wait for events. So this is one thread and one loop, doing an infinite loop. So these two steps can be like evolved into three phases, which is waiting for events on a resource. And when an event happens on one resource, discover which is the event handler, and then invoke the event handler. So the handling of the events happens outside of the event loop, and then you repeat. So resources can be files or network sockets or any operating system low-level resource that's involved in doing I/O. From the perspective of the programmer, the event loop is something where you register an event handler, which is associated with an event on a certain resource. And these event handlers are, in case of Node, JavaScript functions. So the event loop is sitting idle, listening for events on this list of resources that is available. And when an event happens, the event loop reacts to the event and tries to find which event listener is registered for that event on that resource. If it finds one, it executes the function. For instance, it's spotted that this callback function is associated with an event that just happened, and then it executes it. Once that event handler returns, The event loop restarts the cycle, waiting for the next event. So as I said before, the event loop is single-threaded, so it executes a callback function one at a time, waiting for it to return before the next one is invoked. This means that you expect that your callback code will never be interrupted if it doesn't I/O, or basically defers execution code into the future. This is a known feature to browser JavaScript programmers that can do stuff like this without fear of having a race condition. For in this example, which we're using jQuery, there is a variable which is click times, and every time there is a click on any button on the document, this variable gets incremented, and we say a button has been click times. So if this code was multi-threaded, there could be concurrent callbacks being executed, and this code here, this simple incrementation of a variable, has two steps, right? So it has to know which value the variable contains and then increment it, and actually 3 steps: increment it and then save it to memory. So if this was a concurrent call, click times plus plus could be done in parallel by 2 or more threads, and 2 of them are testing it as the value 10. They both increment it to 11, both save it to 11. So what happened here is that we missed a button click. In JavaScript, you don't have to care about those things happening because it's one thread, one event loop. So this greatly simplifies our concurrency concerns regarding programming. So this is the end of the episode. I hope you enjoyed it. On future episodes, we will address more of the Node.js conventions, namely the basic patterns, which are 3: the callback pattern, the event emitter pattern, and the streams pattern. So I hope you enjoyed it, and see you on the future episodes. Bye bye.